Had you guys go on the computer yesterday to do a little cross-section work. Today we're going to have a little background music for some explanations. All right, pyramid. How many bases do we have? One base in a pyramid. Yep, one base. And for our purposes in here, for enriched geometry, the base is going to be could be any regular polygon. So yes, please assume that the base is always regular. All right, please assume the base is always regular. And how can you describe the other faces of a pyramid? Other than the one base, what's the other faces in the shape of? Triangles, yes. Not only are they triangles, they are congruent triangular faces. Oh. Okay, they are all congruent triangular faces. Ooh, ready? Regular pyramid. That's a pyramid where the base is regular. We're always going to be dealing with a regular pyramid in here, okay? Thing I got to get through to you now in the next 3 or 4 minutes. There are actually two heights in a pyramid. Two heights. You got your regular altitude, but now we got this new one called the slant height. All right. Anybody familiar with Mission Impossible? Yeah? All right. Doing some crazy stunts, right? That's how I'm going to try to let you guys know what the altitude and the slant height are. All right. So here's what I need right now. You just got to pay attention to a little demonstration. I actually got to turn this down here. Okay, here you go. Pretend you guys are at the top of the pyramid where the triangles meet. That's got a name, by the way. It's called the apex, if you're wondering. All right, called the apex where the triangles meet. So everyone knows the point where you're at right now. You are hanging just by your hand on that apex. You have a rope attached to you. You drop that rope straight down to the middle of the base. Everyone can picture that rope right now. That is called the altitude. That is the altitude of your triangle. Everyone good? All right, so you're at the apex. You drop the rope straight down. You slide on down to the base safely. You have just glided down the altitude. All right? Where is this other height called the slant height then? So the height, boom, 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 right there, boom, to the middle of the base. All right, that's the altitude, the height. Me, I'm going to refer to it as the Mission Impossible height for obvious reasons. What about this bad boy? Slant height. Everyone go to one of the triangular faces right now. The slant height is the height on one of those faces. Does everyone see that? See the difference between your Mission Impossible height, which is inside the triangle, versus your slant height, which is on one of these triangular faces. Okay? That is your slant height. Now, watch what happens. If I connect the height and the slant height, you know what type of triangle I form? A right triangle. So guess what we're going to be doing a lot of today? Pythagorean Theorem. All right? Pythagorean Theorem. All right? So again, height, I drop it down. Slant height is actually on the face, guys. It's actually on the face here. Okay? Everybody good? All right. I'll just let this roll until it ends. Lateral area now. Lateral area. Explain to me what lateral area was again from yesterday. Everything but. Okay, guys. Take away the base. Take away the base. What's left? How many? Well, in this triangles, right? All of them are congruent. It's the area of all the triangular faces. Go back to last unit. Area of a triangle. 1/2 base times height times the number of triangles I have. I gave you your first pyramid right here. Here's your first pyramid. Lateral area. How many triangles do I have? How many triangular faces do I have? 4. So it's going to be 4 times the area of one of them. Help me find the area of one of them right now. All right, help me find the area of one of them. Well, I know the base. All right, not little Ghostbusters. Sorry, we gotta stop. Maybe at the end. Okay, I have 4 of these triangles. Can you help me find the 1/2 base times height? Ready? 1/2. What's the base going to be? 12. Now, don't fall into this trap. This is not the height I need. That's the height of the pyramid. I'm looking for the height on the face, which we just referred to as what? Slant height. Yes, I need the slant height. And how can I find slant height? What did we just say? Forms a right triangle. 8. Now I'm going to tell you this. This little portion here, always half the base. All right, always half the regular base. So that's going to be 6 for us. Always half the base. So I could have 8 squared and 6 squared give me c squared. 64 and 36. So that slant height will be 10. So does everyone see what these numbers represent? This is the area of one of the triangular faces, and I got 4 of them. So the lateral area. (240 square feet. Are we okay? Questions on that part? What's surface area now? Take the area I just found and add in what now? A base. It's a pyramid, so only 1 base today, not 2 like yesterday in the prism. So add in the base. Same pyramid I've given you guys now. Okay, same pyramid. So the surface area now is your lateral area plus the area of the base. Remember, surface area is the whole thing. Whole thing. So add the base back on. It's the same pyramid. Don't do work all over again. What was the lateral area? 240 plus, what's the base? It's a square, so it's going to be 12 by 12. Add in the base. And yes, we have 240 plus 144. So that should be 384 square feet for the lateral area, for the surface area, excuse me. Questions from you guys here, because now I'm going to open it up to you. You're going to help me out. All right. What do we got next? Find the lateral area. Perfect. All right, lateral area. I know it's a pyramid, so take off the base. You have 4 triangles right now, times 1/2 base times height. You're welcome, by the way, on this one. Some of you don't know why I'm saying that. Base and height, 2. Base and height up here? 10 and 13. So 1/2, 10 times 13. (260 square inches. Now, I don't know. I always put this one on because some kids get freaked out because it's upside down. I don't know. It's still ready. 4 triangles. What's that 7 meters pointing to with the arrow? That's the altitude, my Mission Impossible height, not the height I'm going to use on the triangular face. So 1/2, what base can you use though? 7, all right, little help on finding that slant height now. Half this base, 3.5. So we're going to do a little Pythagorean theorem with that. 3.5 squared plus 7 squared equals your slant height squared. Now, this will not come out to be a nice number. I would just suggest leave it in the radical for now. Okay, just leave it in the radical and then you can multiply it at the end. When you're ready, what do you get underneath that radical that you're taking the square root of? 7 when you're ready? Yep, that's what I'm looking for. I don't want to write out that decimal yet. I could just leave it like that. Now go ahead, everyone, multiply everything through. And that lateral area ends up being, one more time here, 14. Got it. I will let you try 3 out right now. Go ahead on your own or working with other people. Surface area now, everybody. Surface area. The whole thing. Lateral area and the base. Surface area. Cut it in half. Right? Cut it in half, yep. Can you please start with the lateral area for me? 4 triangles times 1/2. How'd you get the base and the height? Here we go. 2, base and the height here. How'd you get it? 1/2. What's the base? 5 times square root of what for the 150.2. Hey, if you guys have a 13 in here, make sure you always take half the base. That's 2.5 in Pythagorean theorem, not 5. Okay, be careful there. Plus the base now of 25. And again, this 50.25 came from 12 squared plus 2.5 squared equals c squared. Any questions where we're getting those numbers? We're all right? So the surface area is going to be 147.6 square meters. Okay, ready to get tricky. Woo! You guys have been dealing with square bases, been pretty darn convenient, right? Square bases. What about a hexagonal base now? Hexagonal prism, or pyramid. All right. No need to get scared. Here we go. Whoa, whoa. I'm not putting a 4 there this time. 6 triangles. Watch it. Watch it. 4 triangles. Yeah, if it's a square pyramid. This is hexagonal. So 6 triangles. 1/2. What's the base? 6. Height, slant height, 12. You don't have to find it. No Pythag needed, right? So there's the lateral area, right? Right there. There's the lateral. Ooh, and then I have to add in what? The area of that regular hexagon. Okay, here we go. Let's go back to last unit. Let me draw the hexagon off to the side. Might be a good idea too. So I'm not messing up my diagram with all these crazy lines. So there's the base. What was our preference in here? 1/2 AP or 6 triangles? Okay, 1/2 AP. So I'll just put 1/2 AP then right here. What's the perimeter then, real quick? Perimeter should be 36, right? All right, we're going to have to do this. The A stood for? That length right there, the apothem. Anybody remember how to get there? I know it's been a unit, but we're going to make a right triangle out of it. Draw in a radii. Can you find how much that angle is? The apothem just bisected that full angle. Mike? Why? This full angle is 60 because 360 divided by 6, 60. And the apothem bisects it, so there's the 30. There's the 60. Hey guys, do you know any side length of that 30, 60, 90? Well, this is all 6 right here, right? So this half of it would have been 3. Where's it across from? Calm down. 3 is across from 30. The apothem, Emma, is across from the 60. So how do I go from the 30 to the 60? Multiply it by radical 3. So there is my apothem. Ooh, a lot of work to do on that one. 3 radical 3. There it is. That base was pretty tricky. Punching all those numbers here. 8, what do we end up with?
309.530746 each square.
It's all right, it's on a different page, but we're going nearest 10 still. Nearest 10 for the surface area. 309.5 square meters. So we are right there. You know, it's not going to be a square base. All right, deal with it. It's not going to be a square base all the time. Oh, and then we have to have one of these. You know it. There they are. There it is. Okay, what 2 solids, what 2 polyhedrons make up this whole thing here? What's on the bottom? Oh, my. Rectangular prism. So I got the prism. And then what's on top? The pyramid. Yep. And I only say that because, don't ask me why, the toughest time spelling that word. The R and the Y, I can never know which one goes first. So that's why I always refer to it as the pyramid. It's embarrassing. It's embarrassing, really. It's embarrassing. So I'm fine admitting it. I have no issue with that. Let's go to the prism. What is showing, right? Not what's covered up. How many faces are showing on the prism? 5. Find the area of all 5 right now. All right, let's take the one on the right and the left. They're both the same, so I'm going to say 2 times. What's the dimensions on the left and the right? All right, 3 by 6. Plus, you want to go front and back now. I got 2 in the front and the back, and they're what by what? 6 by 3. I do not have a top and a bottom. I only have the bottom there, which is what? 6 by 6. So that should take care of the prism. Five out of the 6 faces are showing. 1 is covered up. I do not count it. What's the area of the surface area of the prism in this one? 108. Okay. What about the pyramid on top? Just find the what, Will? Lateral area, because the base is being covered up. So how many triangles? 4 triangles. 1/2. What's the base of one of them?
6.
Everyone see 6 feet here? 6 feet. Times its height, or in this case, the slant height. 4. Everyone all right? Why I'm not adding in the base, even though it says surface area? Base is covered up by the prism. So the pyramid, 48, for a total of 156 feet. Are you okay here with this? Because we try to do one of these a day. All right, with the new figures we have. And you usually see one of them in the homework. Okay, that was fun. Chances you brought your compass today. Compass, Regents exam from this week. We're going to do a construction out of there. There we go. There we go. Indiana Jones. Nice. Nice. Oh, you got the classic.
Lego Indiana Jones World. That's where I was. Lego Indiana. Oh, come on.
Ooh, Teenage Mutant Ninja Turtles. Ooh, that's my league right here. This is my day. Turtle and a half shell. Turtle power. All right, I'm done.
It's so 80.
Calm it down there, bud. That's right up my alley here. Turtles and a half shell. Turtle power. Michelangelo, favorite turtle, if you're wondering. All right, Michelangelo. He was all right. He just had the stick. Michelangelo had the nunchucks and the orange. That's true. He was the brains of the group. Yeah. Okay, go to number 31. Let's review how to do a tangent line. So they provided OA, which is a what in the circle here? A radius, and I know a theorem, if I draw a tangent to the point of tangency, it's going to be perpendicular. So anybody want to lead the discussion here on how to make a line perpendicular to OA going through A? Answer's not always fish. Sean.
We're going to extend OA.
Extend the radius, yes.
And then
Where should I put my compass now?
we're going to put the compass point on A.
Yep, on the point I'm trying to draw the perpendicular line through.
Then we're going to do the perpendicular bisector construction.
No, we're not. Not the bisector construction, just the perpendicular line construction. So what do I need to make an arc right now. What's the purpose of the arc now?
Intersect the line.
And then where should I go with my compass now?
To each point.
Yep, each point. Make two more arcs that will intersect each other. And then line up your straight edge and make sure, and they will take off a point for this. It's a 2-point question. They'll take off a point. It says construct a line tangent, not a segment, not a ray, a line. So put some arrows on that bad boy. Questions at all? All right, let's go to the next one. Can you and your group, or maybe you on your own, figure that one out? Number 28, go backwards, 28. When were these two equal to each other? When were the, and remember, hey, it's giving you a little hint here. R's got to be between 0 and 90. Can't be any bigger than 90. Anybody remember when sine and cosine were equal? The angles are not equal. They're complementary, yes. Sine and cosine are equal when the angles are complementary. Add to 90. So angle R in this case would be 90 minus 73, 17 degrees. Okay, always equal when the angles add to 90. And I don't think one or two more maybe. Oh, our favorite, 26. Other than circles, our favorite. The name of this one, partitions. All right, right away, I'm going to cut it into a ratio of 4 to 5, meaning how many congruent pieces? 9 congruent parts. And I've actually looked into this a little bit more. I'm going to show you a little shorter way than what we've done. I think you'll. I'm going to combine two of the steps into one. Let's go. Remember, we always go x coordinate, y coordinate. All right, somebody tell me where you start and where you end on the x-axis. Start at 4 and move. Whoa, 22. That's a distance of what? 18, right? And then usually from here, what would we do? Divide by the number of, and then multiply by where we're going, right? Well, the same thing can be done if we take that distance and multiply it by 4 out of 9. Because aren't you dividing it by 9 and going to multiply it by 4? That's the same thing. All right, so I can multiply this by 4 out of the congruent parts I need. All right, 4 out of 9. And what's that end up giving you? Okay, hey, that's not my x-coordinate. What's that 8 telling me? That's the distance I got to move from 4. Okay, this is not my x-coordinate. This is saying go 8 units. So from 4, go 8 units, and where do I end up at? 12. Okay, so be careful there. That is not my ending x-coordinate. That's the distance I got to move on the x-axis. All right, let's do the same thing for the y-coordinate. Now you're going from what to what? 2 to 2? Do we have to do this?
0.
Do I have to go through all this?
No.
So what's my coordinate then of point P?
0. Or 2.
12, not 0.
2.
12, 2. Yep, the y coordinate didn't change. All right, and I think, is that it? One more? That's it. All right, we're good. That's what I wanted to get through as far as the Regents exam goes.
We did. Yeah, we got Scooby-Doo.